This is the Math 227 Statistics. Today we learn Chapter 2, Grouped Frequency Distribution and Graphs. Chapter 2, the topic is Grouped Frequency Distribution and Graphs. First question, when the range is large and the classes there are several units in width are needed, which one? Frequency, what frequency distribution is used? A, B, C, D. Which one? A is grouped, B is probability, C is district, D is continuous. This is we call when the range is large and the classes we separate into several classes. There are several units in width are needed. And this we call grouped frequency distribution. So this chapter 2, we learn what is grouped frequency distribution. Let's put one example. Question 2, example. The fruit production in pounds of 15 zucchini plants are listed below. Here has the first zucchini 6 pounds, second 4 pounds, the third zucchini 10 pounds until the total 15 zucchini has 5 pounds. So A, complete this table. Before we complete this table, we already given you class units on the table. This column, class units given. We separate into 1, 2, 3, 4, 5 class. Because number is, look at those number. Smallest one is 1 pound. The largest one is 10 pound. So divide the total 10 pound. The largest one is 10 pound divided by 5 class. Each class is 2 pound. So first class from 1 pound to 2 pound. Second class from 3 to 4 pound. Third class from 5 to 6. 7 to 8, 9 to 10. Class 5. Class, the range is from 1 to 10. The range is large. Classes, there are several units in width are needed. This we call grouped. So we grouped 1 to 2 pound in one group, in one class, 3 or 4 pounds in second class, 5 or 6 pounds in third class, and etc. And the next class boundary. Class boundaries is below 1, 0.5, because 0.5, if you round it, is 1. Round up, it's 1. Until 2.5, not including 2.5. So the boundary from 0.5 to 2.5 will include 1 pound to 2 pound after rounding. Like which is 1 minus 0.5, get 0.5. 2 add 0.5 is 2.5. This is a class boundary. Like a class from 3 to 4 pounds, 3 minus 0.5 got 2.5. Because 2.5 you round, you got 3 pounds. So the boundary is 2.5, the low boundary. The upper boundary is 4. Add 0.5. Get 4.5. So this boundary is the number between 2.5 to 4.5, but not include upper boundary, not include 4.5. Because 4.5 you round it is a 5 pound, so not including 4.5. So all the number between 2.5 to 4.5 you round it, you will get the number either 3 or 4. So 5 minus 0.5 got lower boundary of the class, so got 4.5. 6 at 0.5 got 6.5. It's upper boundary. 7 minus 0.5 got 6.5. 8 at 0.5 got 8.5. 9 minus 0.5 got 8.5. 10 at 0.5 got 10.5. So this class boundaries. Then midpoint. Midpoint is the two numbers add together divided by 2. 1 add 2 is 3. Divided by 2 is 1.5. 3 add 4 is 7. 7 divided by 2 is 3.5. 5 add 6. 11. 11 point divided by 2 is 5.5. 7 add 8. 15 divided by 2 is 7.5. 9 add 10 is 19. Divided by 2 it's 9.5. That's midpoint. Then figure out frequency. When we figure out frequency, first of all, we have to put the number in order. You can look at here, started at 1, then you put the number in order. You started at 1, then 2, then put 3. There's more 3 and put 3. Then 4. There's another 4. Then 5. Another 5. Then 6. 6. 3, 6. Then 7. Then 8. Then last one, 10. Put in increasing order. Then you counted frequency. 1 and 2. There's 1 and 2. There's 2 of it. 2 zucchini. So frequency is 2. 3 pound, 4 pound. 1, 2, 3, 4. 4 zucchini is falling in this class, either 3 or 4 pounds. So 4 zucchini. Frequency is 4. 5, 6. From 5 pound to or 6 pound, it's 1, 2, 3, 4, 5, 6. There's a 6 zucchini is falling in the class from 5 to 6 pounds. And 7 to 8, 2 zucchini, either 7 pound and 8 pound, 2 zucchini. So frequency is 2. Then 9 to 10, only 1, only 10 pounds. Only 1 zucchini, so frequency is 1. Cumulative frequency. So cumulated, it's from 1 to 2 pound. Have 2 zucchini. Frequency is 2, so cumulated is 2. Then from 1 to 4 pound. From 1 to 2 and 3 to 4. So add together. 2 add 4. 2 add 4 get 6. Cumulative. So it's from 1 pound to 4 pound. Total have 6 zucchini. 1, 2, 3, 4, 5, 6. From 1 to 4 have 6 zucchini. So you do 2 add 4 get 6. Then add more. Add the next class. 5 to 6 pound. From accumulated from 1 pound to 6 pound. Total how many zucchini? So it's 6 add 6, which is 2 add 4 add 6. 6 add 6, get 12 zucchini. Is the pound is from 1 to 6. 1 to 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. From 1 to 6. 6 add 6. Total 12 zucchini. Accumulated frequency. Then next, from 1 to 8. So from 12, you add 2 more. It's 7 to 8 has 2 zucchini. So from 12 to add 2, got 14. So from 1 pound to 8 pound, total has 14 zucchini. From 1 pound to 10 pounds, so 14 add 1, got 15 pounds. So have got 15 zucchinis. Total is 15. Here have 15 zucchinis. This we call cumulative frequency. So what is the relative frequency? Relative frequency is the frequency divided by total how many? 2 divided by total 15. 4 divided by 15. 6 over 15. 2 over 15. 1 over 15. We call relative frequency. Then next, construct the following visualizations of the data using the grouped frequency distribution. So this we call grouped frequency distribution table. Use this table to construct. So construct, first one we call frequency histogram. Frequency histogram. We will use class boundary on x-axis. Use class boundary. We started at 0 and 1 and 2 and 3 and 4 and 5 and 6, 7, 8, 9, 10. And we use boundary. You look at this boundary, first class boundary, 0.5 to 2.5. So you find between 0 and 1 is 0.5. Between 2 and 3 is 2.5. This is one boundary. Frequency is 2. Frequency is 2. So on this side is frequency 1, 2, 3, 4, 5, 6. So from 0 point boundary 0.5 to 2.5, use 2, draw this and draw this. Then next is 2.5 to 4.5. So find between 4 and 5, it's 4.5. So this second class. Frequency is 4. So at 4, use the ruler at 4, draw this. Then next, from 4.5 to 6.5, between 6 and 7 is 6.5. Frequency is 6. 4.5 to 6.5, frequency is 6. So you on this 4.5 to 6.5, you draw this to the 6. Then next, from 6.5 to 8.5, frequency is 2. So you could draw 6.5 to 8.5 is between 8 and 9. And the frequency is 2. Draw this. Then next, from 8.5 to 10.5 frequency, it's a 1. So you look for 8.5 to 10.5 and then draw 1. From 1, draw. And label the horizontal line we call full production and put units in pounds. Full production in pounds. On the vertical line, label frequency. On the top, label the title of this graph. This histogram is zucchini production. This we call frequency histogram. In the horizontal line, use class boundary to draw. Use class boundary to draw. Then next one, we draw relative frequency histogram. Relative frequency. Relative frequency is also use class boundary on the horizontal line. So like 0.5 to 2.5, 2.5 to 4.5, second class, 4.5 to 6.5, third class, 6.5 to 8.5, 8.5 to 10.5. That's a class, use class boundary. Frequency. Relative frequency is a frequency over total n. So like first class is 2, frequency is 2 divided by n. N is total, it's 15. 2 divided by 15. So and then you divide it, you got 0.13 bar. It means 0.133333 repeating. In the second class, boundary is 2.5 to 4.5. Frequency is 4 over 15 is 0.26 bar, which is this one double, previous one double. The next third class from 4.5 to 6.5 is 6 over 15. Divided is 0.4. And then fourth class is 6.5 to 8.5. Frequency is 2 over 15. Divided is 0.13 bar. The last one, frequency is 1 over 15, 0.06 bar. And you can use 2 over 15, 4 over 15, 6 over 15, those fraction to draw. Or you can use decimal to draw, either way. So like this one is 2 over 15, which is here. This one is 2 over 15. And the second one is 4 over 15. Here it's 4 over 15. 0.26 bar. Then next 0.4. It's 6 over this one, 6 over 15. The third one. Then next one is again 2 over 15. The last one is 1 over 15, which is this one. 1 over 15 is this. This histogram is the same shape as the frequency histogram. Same shape. That's relative frequency. Same shape. Next one we call frequency polygon. Frequency polygon use midpoint to draw. Oh, okay, I forgot to tell you. Previous one. After you draw it, you have to label. On horizontal line, label full production, parentheses in pounds. And this vertical line, you have to say relative frequency. Relative frequency. Title is Zucchini production. And the next one we call frequency polygon. Frequency polygon use midpoint. Between 1 and 2, midpoint is 1.5. Frequency is 2. And between 3 to 4, midpoint is 3.5. 3.5 frequency is 4. 3.5, 4. Then next is a 5.5. Midpoint 5.5. Frequency is 6. So this 5.5 and this 6, this point. Then next it's 7.5. Frequency is 2. 7.5 between 7 and 8, 7.5. Frequency is 2, this point. Then next 9.5. Between 9 and 10 has 9.5. Frequency is 1. And got this point. And those points connect together. And that's form frequency polygon. Use midpoint on horizontal line to draw. And then after one, and then you go connect this to 0 and this to 10.5 to 0. Normally they put this way. And then horizontal line, you say fruit production in pounds. And vertical line label frequency. On the title, say production of zucchini plants. Next is called ogive, which is a cumulative frequency graph, and use upper bound. So this horizontal line find out upper bound. The first class upper bound is 2.5, then 4.5, then 6.5, then 8.5, then 10.5 upper bound. So look for 2.5, between 2 and 3, 2.5, 4.5, 6.5, 8.5, then 10.5. Each class use upper bound. For 2.5, cumulative frequency is 2. Then for 4.5 upper bound, cumulative frequency is 6. 2 add 4, get 6. Then next, for 6.5 upper bound, cumulative frequency is 6 add 6 is 12. Here, this side is 12. This side label 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until cumulative. Then next, for 8.5, you from 12, you add another 2, get 14. From 10.5, add 1, get 15. And it's a cumulative frequency, which is this 2, 4, 6. This is a relative frequency. Cumulative frequency we did in the previous page here. Cumulative frequency 2, 6, 12, 14, 15. And to draw OG and connect those points, hence we call OG. And you have to label horizontal line fruit production in pounds, vertical line cumulative frequency, title production of zucchini plants. Next, draw the pie graph. And the class limits from 1 to 2, 3 to 4, 5 to 6, 7 to 8, 9 to 10. Relative frequency from 1 to 2, it's 2 over 15 relative frequency here. 2 over 15 for 2, 4, 6, 2, 1. This 2, 4, 6, 2, 1 is the frequency over total. F over N is the relative frequency. This frequency over N is 15. So it's 2, 4, 6, 2, 1. And each one divided by 15 we call relative frequency. And times relative frequency times 360 degree, because we are going to draw pie graph. One circle is a 360 degree. So you go 2 over 15 times F over N. First one is 2 over 15 times 360 degrees is one circle. So you got 48 degree. The next, it's 4 over 15 times by 360 degree, and you got doubled. This double is 96 degree. The next, 6 over 15 divided by 360 degree got 144 degree. Then 2 over 15 you got 48 degree. 1 over 15 times 360 degree you got 24 degrees. Then draw this pie graph. How to draw pie graph? First of all, we need to draw a circle, and you can use compass to draw a circle, or use any round subject to draw circle. Any subject with a round to draw a circle. For example, I have this subject as a round circle. We can draw a circle. Draw a circle. Like a pie. And then there's the middle. You can use compass. Here middle is the center. And then we started on this is 0 degrees. 0 degrees. Then, and use protractor. This one, protractor. This protractor. This is the center, put on the center. And this is the line up with 0 degree. First class, 48 degrees. So go 0, 10, 20, 30, 40, 45, 46, 47, 48. So 48 degree here. Put a dot, connect, and label. This one is from 1 to 2 pound. Percentage, we figure out it's 2 divided by 15, you got 0.13 bar. Move decimal point to the right 2 positions, which is 0.13 bar. 2 over 15 is 0.1333, and etc. Move to the right 2 positions. It is 13.333, and etc. Attach percent sign. And then you round it. You can round up to here. 1 decimal digits, 13.3%. So the first piece is 13.3%. Second one, 3 to 4. Second class, 3 to 4 is 4 over 15 degrees, 96 degree. 96 degree is this Projector, put this at the center, line up 0 degrees. This line up. This is the center and this is 0 degree. Then 96 up to 90, 95. One more, 96. Connect with center. This is a class 3 to 4 pounds. It is 4/15. 4/15 divided. 4/15 you got is 0.26666 and etc. Move decimal point to the right 2 positions, and you will get is 26.666 and etc. Attach percent sign, and you round it is 6, round up, so it's about 26.7%. So you say 26.7%. The next 144 degrees. So you turn this and make here center. The line is 0 degree. 144 degree, 140 degree, here 145, so here 144 degree. Connect with center, and this piece 144 degree, and the mark is from class 5 to 6, 144 degrees. So is the class is 5 to 6. And write down percentage, 40%. 6 divided by 15 divided. Cancel 3, got 2. Cancel 3, got 5. 2/5, it's 40 degree, 0.4. 0.4, it's 40 degree, so label 40 degree. Next is from 7 pound to 8 pound. Frequency is 2/15, got 0.13 bar, same as this, same as the first one. So it's 13.3%. And the angle equal 48 degree. So next 48 degree, how to draw? You turn this. Originally it's here, so you have to, originally it's like this, right? Then here's center, you have put this at 0. Center, this is 0, and you need 48 degrees, so 0, 10 until 40, 45, 46, 47, 48 degree here, and then connect. And this mark, you will say it's 7 to 8 class. Class is 7 to 8. 7 to 8. Percentage 13.3%. The remaining, the last one. So last one you don't need to. So the last one is a 9 to 10 class. Degree is 1/15 is 0.06666. Move decimal point, get 6.66%, and round it is 6.7%. Round to 1 decimal places for the percentage. So here on the graph, you will see 6.7%. And this is a pie graph. Here, draw here, pie graph. For the pie graph, you have a label the class. Here has 1, 2, 3, 4, 5 class. And you have to label each class how many percent. How many percent. It's not the degree of the angle. It's the class and the percentage, relative frequency. Relative frequency, also called percentage frequency. It's a percent in percent. Next one. What is the angle of the piece on the pie graph representing the 7 to 8 class? So you look at here from 7 to 8 class, angle is what? 48 degree. It's 2/15 times 360 degrees. It's 48 degrees. After you cancel, it's 48 degrees. Next, comment on the distribution of the data. So, and you can look at the graph, previous graph, like a histone graph like this, this middle one, midpoint, this histone graph, and then you look like this relative frequency histone graph. If you draw frequency polygon, it's going to be like this. And the graph like this side is fatter, this side is skinner. And then we call skew to the right, slightly skew to the right. So this distribution is this. If this side is fatter and this side is skinner, which is go like this, skinner, and this side is fatter and this side is skinner. This is a skew. This side is the right side. We call skew to the right. And right side is a positive number, left side is a negative number. So this also called positively skewed. Positively skewed. And the other kind, if this way, if this side is a skinner slant and right side is a fat and this side is a slant, this we call skewed to the left, and left side is negative, so also called negatively skewed. And the other one, if they are symmetric, the two sides are symmetric, and then we call normal distribution. This is a normal, bear-shaped normal distribution. Now, there's 3 kinds. So skew to the right, also called positively skewed. Skew to the left, also called negatively skewed. And for this question, you can see from this graph, it's going to be like this, skew to the right. So this is also positively skewed. So the distribution is bear-shaped and slightly skewed to the right. Question 3. An automobile dealer wants to construct a pie graph to represent types of cars sold in June. He sold 75 cars, 25 of which were convertible. How many degrees should be used for convertible section? So degree, angle of degree is a frequency, 25 convertible out of total 75 cars. So 25 out of 75 times pi graph, 1 pi, 360 degree. And this cancel. 360 divided by 3 is 120 degree. So 120 degree. Next, construct stand leaf plots. This one, how to do? First of all, you look at the number 10 digits. 9, 8, 8, 7, 6, 7, 10, 9, 9, 8. This is a digit of 10. Then stand leaf plots. Then we write here, start at 6. 6, 7, 8, 9, 10. That is a stand. We write the stand. 6, 7, 8, 9, 10. Write the stand. Then you look at this. You look at this one. Then 98. To look at the data. 98. Put 98. This is leaf. 83. 83. Put 83. Then next, 88. 88. Next, 76. 76. Next, 64. 64. Next, 77. 77. Next, 100. So 110, 0, 100. Next, 96. 96. Next, 93. 93. Next, 86. 86. So this side we call stand, this side we call leaf. And put those numbers in here, stand leaf plots. So I put this one. Same thing here. This over here. Now I put them in order, in increasing order. From 863 becomes 368, increasing order. 386 becomes 368, 67, 4, and 0. Now put them in order. Put them in order. This we call stand leaf plots. From here, then you can put them 64 is the smallest one. Then next, sorted. Then you can sort it. 64, then 76, then 77, then 83, then 86, then 88, then 93, then 96, then 98, then 100. So then you can sort in order, increasing order. What is the range? The range is what? The largest number minus smallest number. Like this, largest number is 100, maximum 100, minus minimum 64. Range is 36. Range is 36. Next, what is one of advantage of the stand and the leaf plot compared with other data visualizations? They just ask you one, but I list out three advantage. First one is we can see how the data are distributed, like bear-shaped or skewed to the left or skewed to the right. Like this one, you can see this go like this, go like this. Bear-shaped, how they distributed like this. Is bear-shaped or skewed to the left or skewed to the right. That's first one. Second one, we can see how many scores in each class. Like 60s has 1 student, 70s has 2, 80s have 3 scores, 90s has 3 scores, 100 has 1 score. In each class, we can see how many score in each class. Third one, since we use raw data, true data, to construct stain and leaf plot, we can see the exact score, not like histogram using frequency. I cannot see the exact value. We cannot see the exact value. So stain leaf, you can see exact values on the stain leaf plot, not like frequency, group frequency distribution. You only see is the frequency. You only see frequency. This histogram, you only see frequency. This size is frequency. You don't see on this graph, you don't see exact data. You just see the frequency for each